Hi, I'm Muchin, and in this video I will be showing you how to debug your apps on Win60 code in Visual Studio. To demonstrate, I will use the Prelab 3 Part 1. This is a code that's supposed to solve the problem, but there are many errors hidden throughout it. So let's just build and run and see what happens. I'm sure most of you encountered an error like this before. Whenever this comes up, you never want to say yes, you always click no, after which you have a error list that is presented to you, and it's usually nice to click on the top error and figure out what's wrong. So we go through it one at a time. So in this case, it's expecting a file name, and upon closer inspection, we notice that this should not be included, but it should instead be defined. And then we save, and now notice that that error has disappeared from our error list. Move on to the second item, and it says expecting a semicolon, but we look at this and this line is completely alright. So sometimes the error is actually referring to a line before or after, so look around. So you know, nothing is wrong after that line, and it looks like we missed a semicolon on the line before. So that's fixed. Okay, now let's build again, and as you can see, this time the build succeeded. Okay, so as you can see, our output is pretty ugly. First of all, it skipped entering the second parameter, which is the temperature increment, and also we get some negative, really nasty garbage values. So a common way to debug and see what's going on in the program is to add a bunch of printf statements throughout. For example, you know, we can say printf d and num temps. So what this will do is that it'll echo whatever that we entered, but this can be tedious sometimes. So there's another way to do this, and that's using the built-in debugger of Visual Studio. So let's go over some of the debugger basics. On the left side here, we have a strip of padding. This is where we can set breakpoints. Breakpoints are points where to tell the Visual Studio where your program has run up to this point, stop the program, and let you debug. You can remove the breakpoint by just clicking on it again. Up here is where we can start our debugger. We can also start our debugger here from the debug menu and click start debugging. Once another set of icons will appear here once we start debugging. So let's just set some breakpoints and start debugging. We're going to set some breakpoints on all of these three scanfs because we want to make sure that they're working correctly. And let's start the local debugger. Notice that we have now been stopped at the first scanf statement. Our program is not responsive because we are stopped here. The program has stopped, it has paused. So now up here we have the button to stop debugger, so this will close the program. We have the restart, so this will close the program and then restart the program. But we have these three mostly extra icons that we need to care about. First one is step into. So suppose you're calling the scanf function. By clicking on step into, we're actually go into the scanf function. In this case, we don't want to do that, but in future labs where you have to write your own functions, this could be very helpful. Next is step over. This basically execute the current line and then move this arrow to the next line so that we can execute that one on the next step over. And lastly, we have step out. So this is for if you're inside a program, pressing that button will make you go outside the program. Again, in this case, we don't have to worry about that. So let's just press F10 to step over the scanf statement, and we can see that we resume back to our program. So let's enter some numbers. 10. Okay, now we have been stopped. We press F10 again. This will execute this line, which is printf. As we can see, we printed F. And again, scanf. Oh, notice that we skipped the scanf, so what's wrong with that? Well, upon closer inspection, we can see that our format specifier is wrong. We're not supposed to use an ampersand, we're supposed to use a %. We can actually hover over these variable names to see what they actually contain while the program is running. So in this case, we see that Celsius, even though we enter 10, is minus 9 point something times 10 to the 61. So that is obviously not right. So we double check this line again, and we can see that the format specifier for this line is also wrong. So let's change that to LF as well. It's usually better to, once you find a bug, to close the program, fix it, and then rerun the program to make sure we actually fixed it. For the sake of convenience, let's just remove these breakpoints, and you can press F5 or this continue button to resume the program. 10 degrees with an increment of 2 for 5 temperatures. Okay, so now we got some usable output. For 10 Celsius, we get 42 Fahrenheit. This is actually not true, so we need to debug to see why this value is wrong. There's a number of places where we can have a wrong number. We could have interpreted the wrong input in the scanf. It could be something wrong with our calculations here, or it could be something wrong with how we output the value. So we can set a breakpoint in any of these to have a closer inspection to see what it's actually doing. So let's enter the same numbers again. And let's just step over and see what Fahrenheit we get. So we get 42 here. So we know the culprit is on this line. So let's take a look and notice that we're doing integer division instead of a proper fractional number division. So this should fix things. So stop and then run the debugger again. 10 to 5. Okay, in this case, everything is working as expected. I hope this short tutorial is helpful. Good luck on your labs, and thanks for watching.